Hello, everyone. Welcome to the Pachehra Talks. My name is Arun, and I'm Solutions Architect and MCT with Novintech, which is one of the best organization to work with. And today, in our network security, we are going to talk about user-defined routes. This is third video in network security. We are trying to cover the entire security specialist course. We have almost completed everything regarding identity as per the course syllabus, and now the network is our second big module, and this is the third video in network security, where we are going to talk about user defined routes. As you can understand with the name what it suggests, it simply says the routes which are defined by the users. What does that mean? That simply means there are routes which are not defined by users but are there. They are routes. That's the only reason VMs can talk to each other, because somewhere there is some route. For example, let me show you. Just to save time, I have created this little diagram. Let's suppose there is a virtual network, as you can see this one, and we have subnet inside it, and there are VMs running in those subnet. Okay. Now, by default, these VM can talk to each other inside a virtual network. And if you remember, even if you apply the NSG, there were some rules in the NSG which allows traffic between the virtual network. Okay, NSG is just allowing, but who is giving the route is Azure. Azure default routing system giving it a route that you can talk to this VM by default, or these VM can go to internet by default. Okay, if you create any VM in Azure, it has a private IP assigned automatically from your virtual network on in which subnet it is spinning, and when you try to access internet from that Azure VM, you can access the internet. How or why? Because there is a Azure default system route available. I'll show you in the portal as well. Let's take this example further. For example, if you peer your network with another VNet 2, as I'm showing you here, it's VNet 2. There is another VM running in one of the subnet. Okay, and these two virtual networks are peered. Whenever you do that, you do not define any routes or route table, because system acknowledge that and add route by default, and they started talking to each other. But that is by the system for us, for our convenience. What if we want to take over the ownership of the routing and want to control it and customize it as per our need, as per our security needs, to be specific, because that's what we are studying, network security. So what we need to do, we need to define our routes, right? We need to define our routes. A very simple example is when we talk about production environment, it's not that simple as at you see here, right? There is always a firewall somewhere. Maybe there is a, let me try to add one more network here somewhere. Let's suppose there is one more network. Okay, and this is your hub network. Let's suppose it's our hub network, and we do have resources like firewall here, right? And we want to monitor, we want to scan all the traffic which is coming into our environment and getting out of it. So let's suppose this is connected to this and this as well. So if this VM is going to the internet or talking to some other VM, or maybe there is on premises, let's suppose there is an on premises environment as well. Okay, and even on-prem has a VPN connectivity or express route something to the hub network. Let's suppose this is VPN, make it simple. Now, if this VM is going to talk to this on-premises VM somehow through this networking, so ultimately the point is we want all the traffic coming in either from outside internet. Let's suppose this is our internet. If traffic is coming from here, or traffic is coming from here, doesn't matter, it will go to the firewall, and as per the rules it will go to the respective VM. Similarly, VM is going to talk to someone, it will go to the firewall, and firewall will send it to on-prem or internet if it is allowed, or to some other virtual machine. So it's not talking directly to this VM, not talking directly to this VNet, right? It, how are we customizing it? Through very simple UDR. So what are we actually doing? Till now we understood what is UDR, user defined routes. As the name says, we are defining our network routes, we are customizing the routes for the network. Okay, and through UDR we can create all those custom routes. Okay, very simple, we understand this now, why we need it, we, it's clear as of now. So how it actually works, first of all we need to create a route table. For example, this is our route table. We need to create a route table, or maybe we can create it outside. Let's suppose, because it's an outside resource, so let's suppose this is our route table. Okay, here we have added one route. If you go, if you want to go to internet, for example, you need to go to firewall. Okay, it's very high level, and what we do, we take this route table and associate it with the subnet, this one. So what happened, when VM tried to access the internet, VM realize I cannot go to directly because there is a custom route, and custom route always wins over the default routes, right? So it will see where I have to go. I need to access the internet. VM1 will say this, I need to access the internet. So where should I go? Route table will say go to the firewall. Then it will go to the firewall. And firewall will see if this VM is allowed to go to the internet or not. And accordingly, traffic will pass or fail. Okay, very simple. All right, so let's quickly see this in the portal. Let's suppose this is not suppose, this is Azure portal. So what you need to do, you need to go to route tables, route table. Let's create a route for the, it ask for the resource group as usual, give it a name, let's call it a firewall route table. Nothing else is needed anymore, because this is, we are giving a name to a table, then we have to define the routes and associate it with any subnet. Create, it will get created. So while it is getting created, let's understand few more things, like Azure automatically provides default routes. It is clear because we don't do anything when we create virtual network, when we peer virtual network, when we create subnet VM. We have already been through that. So let's take, it is still coming up. So one more thing I just wanted to add, because we, each subnet can be linked to only one route table. You cannot connect multiple route tables to the subnet. Otherwise, it will conflict the traffic. Okay. One route table will say go, another will say don't go. That's the reason you can only connect one route table to the subnet. Let's go to the resource. I'll show you here. Now, here are the routes and here are the subnets. Okay. You click on the route, and from here you can create a route. You can give it a name like firewall route. Destination type are of two type, either the IP address or the service tag. We know what is service tag. We have discussed this many time in our previous videos. Just for now, this is the grouping of the IP addresses that Azure services has, like Azure Storage Account, Azure SQL. That's it, nothing much. Instead of working on each and every IP, they grouped it, and they gave the name a tag, and you can utilize the tag. It will help you rather than make your environment more complex. So IP address, let's suppose we have some IP address. IP address of what? IP address of your destination. That means for us it would be, let's suppose, internet. Okay, next hop type is for us, it would be virtual appliance. Okay, even if you have firewall, you can call virtual appliance here. There is no specific firewall here, okay? But you can have internet, you can have virtual network, you can have virtual network gateway. So many hop type. And you can type the next hop address here. Once it is created, you can simply go to subnet. That's fine. We need not to create. We just need to understand route table, and you can associate that particular route table to any of the subnet, and it will be applicable to all the resources hooked up with that subnet. Now, let's go back. Now, let's check few things as we have seen and understand what we have seen. Let me show you again, maybe. If we go to the routes, there were multiple options under next hop type. We need to understand these options, when to utilize these ones. Okay, let's suppose virtual appliance, we all are clear. This is like a firewall or NVA, next gen firewall or Azure firewall. So you want, if you want all outbound traffic from a subnet to pass through a firewall for inspection, next hop type would be virtual appliance. Okay, so you got to create a UDR with the next hop set to the IP address of your firewall or a virtual appliance, and we will associate that this UDR with the respective subnet as we shown in that example. So virtual appliance is clear. Now there was another one which was VPN gateway. Okay, now traffic from your Azure VNet needs to, let's suppose, securely communicate with your on-premises network. Okay, so what you can do, you can apply the UDR, specify a route with the next hop type of virtual network gateway, directing traffic designed for your on-premises network through a VPN gateway. Okay, so let's suppose there is an organization requires that all the databases queries from Azure to on-premise servers are routed through a VPN to ensure encryption and security. So in that situation, traffic will go to on-premises via VPN gateway. Uh, okay, so in that situation, we can use VPN gateway. Now, there was option like, let's do none. Now, if you want to prevent a subnet from accessing a specific IP address range, okay, so what you can do, you just create a UDR and put the next hop type as none. Okay, which simply means it will drop the traffic towards that particular IP address. So when it is used usually to enhance security, let's suppose a company blocks access from their development environment to their production databases by setting a UDR that drops traffic destined for the production IP range. So you will not do mistake even you intend to or by mistake. So the traffic will be dropped, right? Then that was virtual network. Next hop type. What are these? These are next hop type. So what we are doing with this? Well, overriding Azure's default intra-VNet routing to segment traffic between subnets for compliance reasons. So you can use this next up virtual network. So let's take this example. A healthcare application segments its application and database layers across different subnets with UDRs, ensuring sensitive data flows through controlled paths meeting HIPAA compliance. Let's understand the next hop type is internet. Okay. So next hop type internet in UDR plays a specific role in controlling how outbound internet traffic is managed from your virtual network. Like specifying the next hop type as internet in a UDR explicitly routes traffic destined for external public internet address through Azure infrastructure without custom handling by virtual appliance or other network devices in a VNet. You might be wondering why would we do that? Well, there are some situation scenarios. Maybe let's take an example. Might be helpful to understand. That's the reason it is there as a hop type. So consider an Azure Virtual Network hosting a variety of applications, including a set of VMs that need unrestricted access to various internet services for updates or to access public APIs. So by creating a UDR with an address prefix 000/0, including all destinations, means internet, and setting the next hop type to internet, you direct all outbound traffic from these VMs directly to the internet. This setup ensures that these specific VMs have unfiltered access to internet resources which might be necessary for their operations. Right. So these are the next hop type that we learned here, and their usage when we use it and how we use it. It was pretty clear. Just select the next hop type and the IP addresses, and you can have those routes created for you. Now, there are few key consideration that we should keep in mind. For example, there is some limit. So you need to keep on checking the limits on the Azure portal. Usually we don't create, but you never know. Limits of how many route tables per subscription, how many routes inside a route table, like those. And the most important thing is, let me write down Azure limits. And this is the most important thing. I feel like we should know about it. It's IP forwarding because we need to enable that. For example, a virtual appliance. We need to ensure IP forwarding is enabled on the network interface and if necessary within the appliance. Otherwise, traffic can reach to firewall, but NVA will cannot forward it to the another NIC or another resource. So Azure system, Azure infra needs to know there is IP forwarding enabled. That means this could be NVA, right? Then there is another important thing is conflict resolution. What is conflict resolution? Because resolution. Okay. UDR take precedence over default routes. Which UDR? Like UDR is the routes that we create. The custom routes are the UDR. So UDR take precedence over default routes. To that's how the conflict resolution takes place. And there are multiple scenarios I can talk about little bit. We have time where you can understand how it is picking the routes. For example, this is the simple one. If there is a default route and there's a custom route will always take the precedence, the first one. UDRs have, let me write here, that would be make it more clarity. UDR, let's say higher priority over default system routes, right? Okay, that's fine. There's nothing more to explain here. We have explained too much already. And if you have a longest prefix match, so when there are multiple routes to a destination, Azure selects the route with the longest matching prefix, most specific match to the destination IP address as the priority. For example, if you need to send traffic to 10.1.2.3 and there is a route with the prefix 10.1.2.0/24 or 10.1.0.0/16, 24 and 16. So 24 will take the precedence over a route with the prefix of 16 because it's a more specific match. Okay, so that's there. Then another one is if there is an exact prefix match between route and the explicit IP address. Okay, with an explicit IP prefix and a route with a service tag, then the route with the explicit IP prefix is preferred always. If there is a explicit IP, always take the precedence. Okay. Now, if multiple routes with service tags have matching IP prefixes, Azure evaluates them in a certain order. And what is that order? It's like regional service tags, then top level service tags, then Azure Cloud regional tags, then Azure Cloud tags. So, what are regional service tags, which means specific Regional tags, not tags, tag. Regional tags like storage, East US. Okay, so it is more specific. And what are top level service tags? These are the general tags, not tied to a specific region, like storage. Then we have Azure Cloud regional tags, tags representing Azure Cloud service in specific regions. Then we have Azure Cloud tag. So these are the tags which is available. That's how we take the priority. And the important part, there's one more thing is BGP. BGP overtake always takes precedence over UDRs. Because when BGP is enabled for VPN Express Route connection, BGP routes takes precedence over UDR. This ensures dynamic routing decisions based on real-time network conditions. All right, so this is all about UDRs, and that's how UDR help us to make our environment more secure because we can control the traffic. So what we need to keep in mind or some consideration before uh, planning our routing. Well, there are certain things that we should keep in mind for sure. For example, avoid conflicts. Okay. The very first is avoid conflicts. What conflicts? Be mindful of the priority rules to avoid unintended traffic flows due to conflicting routes. If you are into the customizing of the routes, if the environment's requirement is such, then the route management. Okay, management. Regularly review and optimize your route tables, especially when adding new routes or changing network configuration or adding certain resources. Okay. Then monitoring is something that you should always keep in mind along with the testing, because you should utilize the Azure monitoring tools to test and verify the traffic is flowing as expected according to the defined routes. And where you can see all those routes, effective routes, well, you can have a very good thing I'll show you right now. If you go to, okay, come here, go to virtual machines. If you go to virtual machines, this is one of our virtual machines which is running. And how traffic come in, come out of the virtual machine through the NIC, right? Through the NIC. If we go to network settings, here is the NIC. If you go to the NIC, under NIC you have effective routes. From here you can see how the traffic is flowing, how and NSG IP flow we talked about in the first network security video. How we could use that feature of network watcher to troubleshoot. Okay, if traffic is flowing, from which NSG is allowing it, from which security rule it is denied. Here you can see all the default routes created because there is no route table or UDR is attached as such. Okay, and you can see next hop type is internet, so it is allowed, you can access the internet. If we create any route and attach it with the subnet, then it would be custom route. And let's suppose address prefix this and next hop type is NVA, and we can provide the IP address of that NVA, and the name that we given to our route table will be here, like we gave when we were trying to create was firewall, right? Something like that. It should be more relevant so that by the name you can understand easily why this route was created. Well, that's all about it. I hope it was helpful. Well, thank you for watching and you guys have a wonderful day. Bye bye.